Hello everyone. Well, we're going to continue our discussion of basic or introductory trigonometry and talk about how we measure angles on the coordinate plane. So what's drawn here on the screen is a circle, obviously, and you can see the x and y axis that I've drawn. There's no grid here because we don't actually need the grid, but you can see the four quadrants that we're used to in the coordinate plane. In fact, we could probably label them. Let's go ahead and label them. There's quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So hopefully you have your bearings now of what we're looking at. Okay, this is a circle. We're going to be talking about angle measurements in degrees first and then move on to the angle measurement that we actually use in trigonometry. We don't typically use degrees in trigonometry, but it helps to take a look at it in degrees first so that we see what's going on. Okay, I think you can see that we're divided into four 90-degree angles. Here's one right here. And there are three other 90-degree angles here. What you're seeing on these lines here are the 90 degrees split into three sections. Let me go ahead and mark those. 1, 2, 3. So each of the 90 degrees is split into three sections based on these lines here, this line and this line. And we also have the midway point in the 90-degree quadrant as well. So the first thing you need to know is that when we measure angles on the coordinate plane, we measure angles with respect. We start at the positive x-axis and move counterclockwise around the circle. So if I were to draw that, I would go like this. We move counterclockwise around the circle. That's how we measure angles on the coordinate plane. How many degrees in a full circle? 360, of course. Okay, so let's go ahead and label the angles that we currently have using this positive, this direction, this counterclockwise direction. So if we're starting at 0 degrees, that would be the beginning. This would be 30 degrees. And then since we're dividing into thirds here, this would be 60. And this, of course, would be 90 up here. And then halfway through the 90 degrees would be 45. Okay? Let's just continue with the 30-degree marks. So we've got 90, then we've got 120, 150. Halfway around the circle, which would be 180 degrees. 210, 240, 3/4 of the way around, which would be 270 degrees, 300 degrees, 330 degrees, and then back to 360 degrees. Okay? We can also now label the 45s as well. So we go to 45, 90. Our next 45-degree mark would be 135 degrees. Then we're at 180. Another 45 would be 225 degrees. Then we've got the 270, and then another 45 degrees would be 315. And then the other 45 would take us back to 360 degrees again. Okay? So, again, we measure all angles with respect to the positive x-axis in a counterclockwise manner. Counterclockwise. We can also measure negative angles as well. And the way we measure negative angles is that we go clockwise. So if we go this direction around the circle, those are negative angles. Okay, same amount as we went the positive way in terms of magnitude, but negative. So if I go from here to here, I've moved 30 degrees of measurement, haven't I? But I've moved in a clockwise direction. So this is actually negative 30 degrees. And then I think you can see that if I did this, I would be moving negative 45 degrees. And we could continue around negative 60 degrees, negative 90 degrees. Okay, this would be negative 120 degrees. I'll go ahead and finish it off for you. Negative 135 degrees. Negative, what's that, 150 degrees? Negative 180 degrees. Okay, so we're still moving counterclockwise. Here's my negative 180. So I've got negative 210, negative 225, negative 240, negative 270, negative 300, negative 315, negative 330, and back to 0 again, which would be negative 360 if we measured the angle in a clockwise direction. So unlike what you learned in geometry, where angles were essentially all positive, you can also have negative angles as well when we start talking about trigonometry. Okay, and that's all based on the coordinate plane. All right, so if we talk about two angles, let me get you a term here. If we talk about two angles that have the same final destination, okay, we talk about this side where the angle starts, this side of the angle right here, the positive x-axis, that's considered the initial side. The angle where the the side where the angle ends is called the terminal side. So let's just use this 60-degree mark right here. And let's say that that right there is our terminal side. Okay? Let me go ahead and do it in green just so you can see which angle I'm talking about. So we're talking about this angle right here. Not very clean, but I think you get the point. We're talking about that angle right there, that green angle. Okay? Now, I hope you can see that we can measure that angle one of two ways. We can either measure that angle in the counterclockwise positive direction, in which case that angle has a measurement of 60 degrees, or, as we just said, we can go all the way around the circle in a negative direction, and that angle is negative 300 degrees. We say that any pair of angles that have the same terminal side are called coterminal angles. So what I'm telling you is that negative 300 degrees and 60 degrees are coterminal angles because they share the same terminal side. When you start at the initial side, you start at the positive x-axis and you go either negative 300 degrees around the circle, that's clockwise, or you go counterclockwise 60 degrees, you end up in the same place. So that makes them coterminal. Now you might also wonder, are there any other coterminal angles for the 60? Well, sure there are. What if we went around the circle more than once? What if we went, let me use some blue here. This is getting crowded, this circle. What if I went from my initial side and I went past my angle and came all the way around and back to it again? Wouldn't that be the same angle, another coterminal angle? It was the same initial side, but I ended up at the same terminal side. So it's still coterminal. So what did I do? I went a 360-degree turn all the way around the circle and then back another 60 degrees. So another coterminal angle for this, this 60-degree angle here, would be 420 degrees. And I hope you could see that we could go around the circle twice. We could go around the circle 3 times, as many times as we go around. And each time we go around, we add another 360 degrees. So the next one would be 780, and so on, right? Another 360 degrees. Another 360 degrees from that would be, do the math quickly in my head here, what is that? 1140, right? And so on. So all of these angles are all coterminal angles with 60 degrees. So I can find my coterminal degrees, or I can find my coterminal angles. One way I can find them is by to add multiples of 360. But I could also find coterminals by subtracting multiples of 360. My diagram's kind of crowded here, but I hope you could see that I could have gone I could have gone clockwise in the negative direction, one full turn of the circle, and then that negative 300 again. Okay? So, to find coterminal angles, well, let's wrap everything up then. We measure angles with respect to the positive x-axis, counterclockwise for positive, clockwise for negative. Okay? And to find coterminal angles, you add and subtract multiples of 360 degrees to add full revolutions to those angle measurements. Let's do one quick example. Let's say I had the measurement 210 degrees. And I said, what are the coterminal angles for that? Well, I could add 360 to it and get 570, or add 360 and get 930 degrees, and so on. I could add multiples of 360, or I could subtract multiples of 360. If I subtract 360 from that, I get a negative 150. Not surprising. Take a look right there. Or I could subtract another 360 and get negative 510 degrees. These are all coterminal angles. So again, coterminal angles we can get by adding and subtracting multiples of 360. Thanks.